All right, welcome to the Apigee Deep Dive. This is part of our Quickstart series. We're going to be taking a closer look at some of the more technical and in-depth aspects of using Apigee. We'll be covering a range of topics to help you understand how to really leverage Apigee for your API management needs. So here's what we're going to be covering in the deep dive sessions. We'll start with a quick recap of the foundations. Then we move on to proxy building, how you can actually build proxies. Then we'll talk about security, a crucial aspect of any API strategy. Then we'll look at analytics to understand how to monitor, gain insights from your API traffic, followed by publishing, which is all about making your APIs available to your consumers or your customers. So before we jump into the deep dive, let's quickly touch on the foundational concepts of Apigee. These have been covered in detail in the previous foundational Quickstart video session, but for those who have missed that, here's a super fast intro. So this slide gives you a high-level overview of Apigee's API management capabilities. Apigee is a full lifecycle API management platform, and here you can see it covers the developer ecosystem, API analytics, and API gateway. We're going to be touching on a lot of these aspects in a bit more detail in today's session. But on the developer side, we obviously cover, API catalogs, onboarding, API products, API monetization, super important to get more value out of your APIs, and also an API marketplace. And on the analytics side, we have full spectrum coverage for operational, API monitoring, security monitoring, business metrics, everything you need to understand how your APIs are functioning and how you can deliver value again to your business. On the API gateway side, full coverage there on the security, transformation and orchestration, very powerful actually for an API gateway. Apigee is able to do complex transformations from JSON, from XML, and also we have the capability to be able to have shared flows. So the shared flows are, if you like, a kind of custom policy. So you can reuse your functionality across your APIs. And on the caching side, we also have lots of options. And the last one there is actually an iPaaS. We actually have what's called a application integration, which is an iPaaS platform, which is an add-on to Apigee as well. So, and on the deployment side, full flexibility. So cloud, multi-cloud, hybrids. We have an Envoy adapter for your workloads which are running on containers. And again, we can really cover any backend API, wherever it may be, with connectivity from GCP. So let's get into the core of API management with Apigee, proxy building. This section will focus on how you can create and configure API proxies, which act as the front door to your backend services. So the foundational building blocks of an API proxy are policies. And policies are where you define what you want to happen to the API requests and responses as they flow through Apigee. So as you see here, policies are broadly categorized into managed traffic, secure APIs, transform and translate, and extensibility with different options like Java callouts, Python, JavaScript, etc. So again, full coverage. This is only really a short, or if you like, a subset of some of the policies which are available. And again, you can even create your own type of policies, or if you like, a shared flow for your own company functionality, which needs to be shared across different proxies. So again, full coverage there for any kind of functionality or policies that you may need to cover using an API management solution. So while policies define what happens in flows, the actual flows themselves define when those policies are executed. So this diagram illustrates the different stages of a request and response flow through an API proxy. You have proxy endpoints which handle the client-facing side, and you also have target endpoints which interact with your back-end services. So within each endpoint, there are request flows and response flows. Each of those is further divided into a pre-flow, conditional flow, and post-flow, giving you precise control over the sequence of policy execution. And again, you can inject functionality or logic into each one of these flows, and you probably want to do this depending on what kind of functionality you require for the request and response payloads. So the target endpoint is where you configure how Apigee connects to your backend services. It specifies the backend service to call, and it allows you to modify the backend request and response, set connection timeouts, and validate the status codes and payloads of the backend responses. So this is one of the parts you're going to use a lot. Again, you can manipulate the payloads, and you can even catch the different kind of status codes which come back. Again, a lot of functionality here for your behavior of your target endpoints. So an API proxy can have multiple target endpoints. This allows you to route requests to different backend services based on certain conditions. Sometimes a proxy might not even need to call a backend, so handling the entire request and response itself. So how does Apigee actually decide on which target endpoint to use, especially when there are multiple? Well, that's where route rules come in. So after the proxy endpoint request flow, the required route rules are evaluated in order to determine the appropriate target endpoint for a given request. And then the first matching route rule is the one that's used. So key thing to remember about routing rules is that they have an optional condition. If no condition is specified, the rule automatically matches. They also have an optional target endpoint specified. So if a matching rule doesn't specify a target endpoint, the execution continues with the proxy endpoint response. So always the best practice is always to have a last route rule with no condition. So this acts as like a default route. Now let's talk about reusability with shared flows. So a shared flow is like a single flow of reusable logic containing policies, conditions, and resources. It's hosted at the organizational level and deployed to an environment. So importantly, shared flows cannot be invoked directly. They're used by proxies or other shared flows deployed in the same organization and environment. It's just like a reusable piece of custom functionality that can be shared across your different flows. So in this way, you can have like a custom policy which you can apply to lots of different proxies. You build once and then you share across your enterprise. So how do you actually call these? Well, you call these through what's called a flow callout policy. That's how you actually invoke a shared flow within an API proxy or another shared flow. So you simply specify the name of the shared flow you want to call. So remember, the shared flow must be deployed onto the environment before any proxy or shared flow using it can be deployed. So for governance, Apigee provides flow hooks. Flow hooks allow you to attach a shared flow to a specific point in the request response lifecycle of all proxies deployed in an environment. So there are 4 flow hooks: the pre-proxy flow hook, the pre-target flow hook, the post-target flow hook, and the post-proxy flow hook. So again, this is a way for you to make sure that you have functionality which is always applied to proxies in your enterprise. So here's a quick description of each flow hook. So a pre-proxy flow hook, it executes before the proxy endpoint executes, and then the pre-target flow hook, that gets executed before the target is actually called. And then on the way back, the post-target flow hook executes after returning from the target, and the post-proxy flow hook executes after the proxy endpoint finishes and immediately before the response is sent to the client. Flow hooks are configured on the environmental configuration page in the UI, and you need obviously admin privileges to set up a flow hook because it's set at the enterprise level. So importantly, you only have one shared flow per hook, but shared flows themselves can be nested using a flow callout policy. So why would you want to use shared flows actually? Well, they allow you to define a common set of conditional policies that can be reused across multiple proxies, ensuring consistency. This can be used for security, for traffic management in the proxy pre-flow, steps to connect to a service, format conversion, or any common code, especially in large organizations where maintaining many similar proxies would be potentially challenging. So moving on to mediation. So this slide highlights the format conversion pattern. Often backend services might not accept or return data in the exact format that your app developer needs. So Apigee allows you to bridge this gap. The extract variables and the assign message policies are key here. They enable you to extract data from the original message and build a new message in the desired format which your endpoint might require. It could be, for example, a different system like Salesforce or any kind of endpoint which requires a different format. So you have the opportunity to massage the payload as it comes through Apigee. Again, it's a powerful transformation engine. So the extract variables policy does what its name suggests. It extracts information from different parts of a message, like the headers, the query parameters, the URI paths, or even the payload, and it puts the results into variables for later use. You can also set the ignore unresolved variables to true if some of the variables are optional. The extract variables policy can also be used to extract data from JSON or XML payloads using JSON path or XPath respectively. However, it's crucial to note that the Apigee will only pass the payload as JSON or XML if the content type header of the request or response is set to the corresponding type. So do remember to do that. The assign message policy is a very powerful tool for manipulating messages. You can use it to create or change any aspect of a request or response, including adding, setting, copying, or removing headers, query parameters, form parameters, the payload, and for example, the HTTP verb, and even status code. And you can even create new flow variables using this policy. So again, really powerful, enables you to basically build any payload or massage a payload to whatever it needs to be sent to your target or even back to your caller as well. To make the assign message policy even more dynamic, you can use what's called message templates. So these allow you to embed variable names which are enclosed in curly braces and even call built-in functions within policy configurations and target endpoint elements. This enables you to perform tasks like base64 encoding, time formatting, and even JSON path to manipulate data on the fly. Another important mediation pattern is orchestration. This involves calling multiple backend services within a single API request response. So this can improve scalability by combining multiple steps into one operation or by enriching data from third-party services. The service call-out policy obviously can be used to call out to these services during the request and response as well. So again, this helps with enrichment. So this is the primary way to implement orchestration in Apigee, the service call out. It allows you to call to another HTTP or HTTPS service from your proxy flow. So you just configure the request details, the header, the query parameters, the payload separately from the original proxy request and response. So this is often used to add features to an existing backend API. So for example, someone calls your API, you need a bit of extra information from another system, you can call out to that system, get that data back, and then you can use the assign message policy to massage the payload and then push it to your final endpoint. Apigee also supports what's called proxy chaining using local target connection. What does this do? Well, it allows you to call other API proxies within the same organization and the same environment. And this can be super useful for reusing common logic encapsulated in different proxies. And the main thing to remember here is when you're using local target connection within a local target, the request stays entirely within Apigee, improving performance. So again, this is more having a composable architecture of different API proxies. You might want to do this for example, reusability or encapsulation. So sometimes the out-of-box policies might not provide the exact functionality you need. In such cases, Apigee allows you to add custom code to your proxies using JavaScript and Java policies. So it's generally recommended to prefer the out-of-the-box policies when possible because they tend to perform better and they're easier to debug. However, the option is there for you, and it provides flexibility for you to have custom logic in there if you want to in your custom code policies. So the JavaScript policy allows you to also have custom compiled server-side JavaScript code within the context of your API proxies. Again, this is a super useful policy. You use it to get, set, and remove flow variables. You loop through logic, potentially, modify JSON, XML payload, and even multiple HTTP services in parallel using the HTTP client object. So there is a maximum time limit for JavaScript execution, which is 200 milliseconds for trial organizations. So when using the JavaScript policy, you have access to a rich object model. The context object is central, providing access to Apigee variables and flow information. The crypto object also allows you to perform cryptographic operations and time date formatting. And the context.session object can be used to pass variables between different JavaScript policies within the same flow. So for debugging your JavaScript code, you can use the print function. This will output messages to the console, which can then view in the trace tool within Apigee. It's making it easier to understand what your custom code is doing. The Java callout policy also allows you to run custom code within your API proxy flows. You need to package your Java class in a jar file and make it available to Apigee. But do be aware that most system calls are not allowed for security reasons. Java callouts are generally harder to maintain and debug compared to JavaScript as the code is stored in jars. So do think about when you need to use JavaScript, and if there's an existing policy that you should be using as well. And the final thing to think about there is they're not available in trial organizations. Apigee also has a Python policy. So in general, it's recommended not to really use it because of performance reasons. However, if you need to use Python in your proxy, you can do that as well. It's interpreted at runtime using Jython. So there are some serious performance implications with it, meaning it's not super fast. But again, if you need to use it, then it's there for you. In most cases, it's probably better to try and convert that JavaScript code into Python instead, or into JavaScript instead, or maybe even custom code. So choosing between code policies. So when should you use custom code policies? Well, as a rule of thumb, use out-of-the-box policies wherever possible, like assign message and extract variable. Use JavaScript for general manipulation, especially with JSON or XML, when the code will be more intuitive, and it's generally the default choice for custom code. Then maybe use Java if the performance is the highest priority, or if you need to use specific Java libraries. Avoid Python due to its performance limitations. Now let's talk about fault handling in Apigee. So faults in Apigee are similar to exceptions in programming languages. When a fault is raised, the normal flow processing is aborted and the execution flows to the fault rules section for the current endpoint. Importantly, processing never returns to the original flow. You can have multiple fault rules defined within a proxy endpoint or target endpoint, and only the first fault rule condition that matches, or the first one without a condition, is executed. A critical point to remember here is that the fault code conditions are evaluated in reverse order in the proxy endpoint, which is unique within Apigee. In the target endpoint, they're evaluated in normal order. So it's good practice to define a default fault rule. This acts as a post-processing or catch-all rule. If always enforced is set to true, then this rule always runs at the end of the fault rule. If it's false, then the rule runs only if no other matching rule was found. So this allows you to ensure a consistent error response is always sent back to the client. Faults can be initiated in several ways. So the first one is any policy failure when the continue on error flag is set to false, which is often default, including uncaught exceptions within JavaScript code. The second one is a non-success response. So this could be a a 400 or a 5xx status code by default received from a service call out or from a backend request. So you can customize which status codes are treated as faults using the success codes property in the target endpoint. So by explicitly using a raise fault policy. The raise fault policy allows you to manually raise a fault to cause an exit from a normal flow, typically based on a specific condition. The fault response section within the raise fault policy lets you define the error codes, status code, reason phrase, and payload directly within the policy without needing a separate fault rule or assign message policy. However, fault rules will still need to be evaluated after a raise fault policy is executed. So what about the 404 not found pattern? So the best practice for handling unexpected requests, the 404 not found pattern, the idea here is to only whitelist operations to be called in your API. What you can do is you can create a conditional flow for each allowed operation. The last conditional flow should have no condition and simply raises a 404 fault. This helps prevent attackers from trying to access private backend operations by sending requests that don't conform to your defined API. Now shifting gears to security. So this is a core tenet of API management, and Apigee provides a comprehensive set of features to help you secure your APIs. So Apigee aims to be secure as standard, offering a end-to-end security, threat protection, and integration with cloud identity and access control. It supports industry standard security protocols like OAuth, SAML, and JOT or JWT. Apigee also helps with compliance requirements like PCI and HIPAA. So this slide provides a more detailed view of how Apigee addresses security and governance across the API value chain. It highlights different areas like threat protection with built-in policies, advanced API security. We have a session coming on that a little bit later. So that's about AI and ML controls of API traffic. Super interesting. Cloud Armor and reCAPTCHA. Access controls for OAuth, API keys, API products, self-service, single sign-on, governance, rule-based access control, data masking, and data security with TLS or MTLS encryptions. So we just discussed just now Google Cloud Armor. So again, this is a separate product to Apigee, but one that can be used together with Apigee on the same platform. So it's also it plays a crucial role in security of APIs as well. So and Apigee works well with Google Cloud Armor, especially for DDoS attacks and bot protection. So Google Cloud Armor helps mitigate infrastructure DDoS attacks. It allows you to block or rate limit traffic based on various parameters, and it can defend against your application layer attacks using WAF rules to mitigate OW ASP top 10 vulnerabilities. So if you like, Google Cloud Armor is your protection for your API management platform, and your API management platform is your next layer protection for all your applications and for your payloads, where all the AI is run with potentially advanced API security. So Apigee Advanced API Security builds upon the standard security features by providing more intelligent behavior-based threat protection. It uses heuristics and machine learning to identify suspicious patterns, provides alerts and integrates with security monitoring tools, and allows you to quickly respond and to investigate security incidents. This slide visually represents how Google Cloud services work together for DDoS and bot protection. Cloud Armor provides the defense at the global edge, protecting web apps and APIs hosted on Google Cloud, other clouds or on-premises. Apigee provides intelligent API defense within the API management layer. reCAPTCHA Enterprise offers advanced bot and fraud detection using client-side challenges. Here's a summary of some of the capabilities offered by Google Cloud Armor, including level 3 and 4 DDoS defense, IP and geo-based rules, etc. So Apigee can also act as an AI gateway for your large language model usage. So large language models are being attacked at more than more. So common API operational challenges that we see are, for example, distribution and usage limits, safety and security, latency, performance, reporting and governance, and availability. You want to be able, your large language models to be up and to know that they're up and running. So for success in generative AI consumption, together with Apigee, you need to think about security, governance, and operations. So Apigee can help in all of these areas. So we can help you protect your large language models and GenAI applications with Model Armor and Apigee. So Model Armor is an additional product within Google who can help you sanitize your prompts and your responses back from large language models. You can do this directly within Apigee through a policy. We also help you, for example, to do governance with platform security and logging, and also with our advanced API security capabilities, we're able to detect when there is malicious AI attacks happening. So how would you protect your large language models with generative AI, with Model Armor and Apigee? Well, you would simply just use a policy to do sanitization for your calls to Model Armor, and in that way you can detect when there are malicious prompts being sent to your large language model, or if there's toxicity, for example, coming back. Here's an example of that in action. You can see here I'm executing a request from our model garden, suggest a name for a flower shop, and now I'm going to change that prompt to something a little bit malicious. And you can see here I'm sending some financial question, and Model Armor has successfully seen that it's some financial information. So again, when that's executed from Apigee, you can block that with a 400, and then you can take action on that. Another functionality you can use through Apigee for large language models is semantic caching. It can help you improve performance and improvement cost and optimize costs by securing and reusing your calls to your large language models. Apigee can also help you with model routing. So if you're using different large language models in the background and you want to route, for example, to a different model based on different capabilities, you can do that through Apigee. And of course, also analytics. You can see what kind of prompts and how many people are sending prompts through the base analytics. So what would that look like through a large language model and Apigee? Well, you can see here you would actually call your large language model through Apigee, and then Apigee would then go and call a vector embedding to see whether the actual request had been sent before, and if it had been sent before, then it can return the response from the cache because the response should be the same. So here's an example of that in action. You can see here I'm sending a request for a name for a flower shop. That's taking 5 seconds. I'm executing this again. You can see now it's taking 229 milliseconds. That's coming back from the cache. And here I'm executing it again. I'm saying, why is the earth round? And you can see here this is taking 8 seconds because it's a new request. And now I'm going to send a similar request, and I expect it to come back from the cache because I'm asking a similar question just in a slightly different way. So here is the semantic cache in action. You can see it's taking 223 milliseconds. So Apigee can help you also with AI products and chargebacks. So in the same way as you can have an API as a product, you can have your access to large language models through API products. And in that manner, you're able to do chargebacks for usage on your large language model. You're also able to share your access to your models through a custom model garden and have advanced visualizations of usage. So here's an example of what a model garden may look like. Similar to an API portal, you create one specifically for your large language model. And then, once you can see the analytics of your requests running through your API management or Apigee platform, you're able to see consumer-specific analytics. So again, you're looking at distribution, you're looking at safety, latency, performance, availability, reporting, auditing, and troubleshooting. All these areas is where Apigee can help you. So this slide illustrates the security incident workflow within the Apigee Advanced API Security product. Involves detecting critical alerts through heuristics and also machine learning, and then alerting stakeholders with relevant information, and then triaging to drill down to root causes and acting to respond to malicious activity quickly, such as blocking or redirecting suspicious traffic. So moving on to analytics. So understanding how your APIs are being used is absolutely crucial for making informed decisions and improving your API program. Apigee provides out-of-the-box dashboards that give you a unified view of your traffic. You can also create custom metrics and reports, enrich data with custom fields using data capture policy, query analytics data via the API, and export data to BigQuery or storage buckets for a more in-depth analysis. So here's an example of what API metrics looks like. Here you see API proxy performance. You can see average transactions per second. You can see traffic information, average response time, traffic by proxy. Again, essential for API management. You can also see API code analysis. Here you can see, for example, proxy errors, target errors, errors by proxy. So you can drill down into the details. For the latency side, you can also see here response times, target response times, request processing latency, and response processing latency. Apigee's custom report capabilities allow for a high degree of customizability. You can build reports based on the dimensions and metrics that are most important to you. The drill down feature lets you dig deeper into the analytics data. You can also export reports into various formats for long-term analysis of large data sets. Async processing is also available, and you should also consider retention policies for your analytics as well. Finally, let's discuss publishing, which is how you make your carefully crafted APIs accessible to the developers who will consume them. The key concepts in Apigee's publishing model are API products, developer apps, and developers. API products bundle your API proxies and their endpoints. Developers register their applications or developer apps to use these products, and then developers represent the consumers for your APIs. API productization is about abstracting API production from consumption and providing new value to the business. Think of it like organizing Lego bricks into box sets. Your group-related API endpoints into logical products with different access tiers like gold, silver, bronze, and associated quotas and potentially monetization rules, making it easier for your developers to understand and consume your APIs. The developer portal is the storefront for your APIs. Apigee offers different options: the integrated portal, which is basic but very quick to set up, the Drupal-based portals, which are highly customizable and offer an advanced feature. And there's also an option to build a custom portal using Apigee's management API if you have specific needs or existing portal technology, if you like a headless portal. You can control access and visibility of your APIs using developer programs, teams, and audiences. This allows you to segment your developer community and tailor which API products are visible and accessible to different groups. As we mentioned earlier, there are more advanced analytics and customizable dashboards beyond what Apigee built-in tools can offer. You can leverage what's called the Looker Studio. Since Apigee can export its analytics data to BigQuery, Looker Studio can connect to this data source and allow you to create rich visualizations and reports tailored to your specific needs.